Subliminal learning sounds terrifying, a model secretly passing traits through innocent data. But this paper pushes back with a skeptical, mechanistic question. Before we panic, is this a deep property of neural networks or a fragile side effect of how we fine-tune them? For answer, it's largely a LoRA artifact. First, the effect they are investigating. A teacher told to love cats generates nothing but number sequences. A student fine-tuned on those numbers ends up loving cats too, even though the data is filtered to remove anything cat-related. That's the puzzle. Now, almost all of these experiments fine-tune with LoRA. Instead of updating every weight, LoRA freezes the model and learns a small, low-rank update, the product of two skinny matrices, added on top. The rank controls how expressive that update is. And here's their first key result. The strength of subliminal learning follows an inverted U shape in the LoRA rank. If the rank is too low, the effect barely appears. If it's too high, it vanishes again. It only shows up in a middle band, and different traits peak at different ranks. Why a sweet spot in the middle? Their interpretation is that at those ranks, the adapter is just expressive enough to fit the numbers, but not expressive enough to fit them cleanly. So it finds an entangled solution. Matching the teacher's numbers unavoidably drags along the teacher's trait. Cleanest piece of evidence. If you throw out LoRA and fine-tune the full model instead, subliminal learning disappears. Full fine-tuning has enough freedom to fit the numbers without borrowing the trait. So the effect is tied to the low-rank constraint itself. Their second big finding is about context. The trait only shows up if the student sees the same context at evaluation that it saw during fine-tuning, in particular, the same system prompt. Change the surrounding context, and the hidden behavior goes quiet. Concretely, fine-tune QN with its default system prompt in place, and it picks up the trait. But generate from that same student without the system prompt, and the subliminal behavior mostly evaporates. Trigger is literally the boilerplate text around the conversation. It gets more precise. The effect localizes to computation at specific token positions the model saw over and over during fine-tuning, like the default system prompt and the standard chat template tokens. The trait lives at those exact tokens. Here's the smoking gun. If you selectively switch off the LoRA adapters at just a few tokens, like the word QN inside the default system prompt, during generation, the subliminal effect collapses. A handful of token positions are carrying the entire behavior. This fits a token-level mechanism. Promoting one token's probability unavoidably nudges other, correlated tokens. Related work found the signal lives in a few divergent tokens, where student and teacher disagree, and masking those tokens during fine-tuning erases the effect entirely. So what's the verdict? Subliminal learning is real, and actually more common in open models than earlier work suggested. But it's fragile. It needs the right LoRA rank, the right context, and specific trigger tokens. It's an unstable channel, not a robust general threat. So the takeaway: this paper reframes subliminal learning as a fragile artifact of low-rank fine-tuning. An inverted U over rank, gone with full fine-tuning, and pinned to specific context tokens. It's a valuable, sobering counterweight, the kind of skeptical mechanistic work good science needs. Subscribe for more papers, decoded in full,